What? This is a difference of squares again, right? You can do a difference of squares on that. Does this factor? Does x squared plus a squared factor? No, there's no formula to break this down. Not that we don't have one. There isn't one, all right? So x, well, as long as we're not talking about complex numbers. Y'all agree with that? Okay, so now we get this, we get what we wanted. We get the x minus a to cancel. So what you're left with here is limit x approaches a of x squared plus a squared times x plus a. And at this point, you can let all the x's become a's, which would give us no more limit, a squared plus a squared times a plus a. Is that right? What's a squared plus a squared? 2a squared. Okay, times, and then here? 2a. And this is 4a cubed. There it is, 4a cubed. That's your general formula. That is your derivative. That is the derivative of this function at a. Okay? The derivative of this function at a is 4a cubed. We've answered the question. How are we doing? 8 minutes. Okay, let me tell you what I want you to look at for homework. We're not done, but we're still in 2.1. So here's what I recommend you look at for homework for 2.1. I already told you last time to do, what, the first, like 3 through 6, right?
Yeah, 3 through 6.
3 through 6. Okay, now for the rest of the weekend, just look at 25 through 30. Yeah, look at those. So in terms of the exam that you're going to have next week on Thursday, the problems that I will ask you on the exam would come out of 2.1, would come from that set or what I gave you last time, 3 through 6. Okay? All right. I have 7 minutes. I want to show you something that we're going to need next class. Okay, we're going to need this next class. So I'm going to just set it up right now. And that way I can reference it pretty quickly. So this is not just like random useless information just for fun, for me to waste time. Man, it's going to be tight on time. Let's see what we can do. It's going to take up quite a bit of space, so I'm going to clear this whole thing out. Everyone have these? All right. So I'd like for you to consider something. I'm going to write something down. I want you to just think about what this is. If I write x plus h and I raise that to the 0 power, what's anything to the 0 power? Other than 0 to the 0, what's anything to the 0? 1. Okay? So we all agree that this is 1? I'm going to put the 1 right here. All right. Now I'd like for you to think about what x plus h is to the first power. So anything to the first power is itself, right? Just itself. So that's x plus h. I'm going to put that like this. All right? Now I want you to think about what x plus h squared is. Now that's not x squared plus h squared, right? You would actually have to do x plus h times x plus h and FOIL, right? And you would get x squared plus xh plus xh plus h squared if you FOILed. And then you combine the two terms in the middle together and get two xh's in the middle. So that would look like this. X squared plus 2xh plus h squared. Do y'all see I'm creating this triangle? Getting there. Yes? What about x plus h cubed? Wouldn't that mean you have to do x plus h times x plus h times x plus h 3 times, right? And then multiply it all out and then collect like terms. So I'm not going to show the work, but I'm going to tell you what it is. It's x cubed plus 3x squared h plus 3xh squared plus h cubed. That's what it is. Take it on faith. Is that all right? Then if I did x plus h to the 4th, then you would multiply it 4 times together and then collect like terms and you get something, right? I'm going to tell you what that is. Anyone know what it is? X to the 4th? Anyone know? Plus 4x cubed h, good, plus, anyone know the next term? 6x squared h squared, good, plus, you know the next one? 4x h to the 3rd plus, there's one more, h to the 4th. Okay, so you're not doing that in your head, right? Like you're not like multiplying x plus h 4 times, right? There's a pattern here that we need to see, all right? This is why I'm showing this to you. So I'm going to go one more line, see if you can pick up on the pattern. X plus h to the 5th. So let's see, what's the pattern? The first one, right? All these first ones are just x to whatever the power is here, right? So this first one should be what? X to the 5th. Okay, let's not think about the numbers here, right? Let's not look at the numbers here. Let's just look at the x's. What happens to the x's as you move from left to right? What happens to the power on the x's? They decrease by 1 each time. Simultaneously, what's happening to the powers on the h's? They're growing, right? There's no h here, then there's an h, then h squared, then h cubed, then h to the 4th. And that's the pattern for all these lines, right? X powers go down, h powers come up. So I should have here plus, let's not worry about the number yet. X to the what? 4th. Then I should have an h, right? Plus some number, let's not worry about it. Then what? X to the 3rd, and then h squared, and then plus some number, let's not worry about it. What? X to the 2nd, h to the 3rd, plus some number, let's not worry about it. Where are we? X, h to the 4th, and then plus, what about the last one? There's no x's in it, it's just h to that power, that whatever the power on the factor is, right? So h to the 5th? That's the pattern. We just need to figure out what the numbers are in front. So to get the numbers in the last 30 seconds that we have of class, I want you to look at just the numbers on all of these things. There's a 1 here, there's a 1, and there's a 1. There's a 1, there's a 2, there's a 1. There's a 1, there's a 3, there's a 3, there's a 1. Y'all got it? I'm going to draw those over here. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, what, 5, 1. Okay, so do y'all see it? What's happening? Any number on this triangle is the sum of the two numbers above it. So this 4 is the sum of the 3 and the 1. This 6 is the 3 and the 3 added together. This 4 is 3 and 1. This 5 is the 1 and the 4. The 10 is the 6 and the 4. The 10 is the 6 and the 4. The 5 is the 4 and the 1. This is called Pascal's triangle. It was actually discovered by the Chinese, but Pascal gets credit for it. That happens a lot in history, right? Other people do all the hard work and then someone else gets the credit. So this should be a 1. Then what's this number? You're adding those two numbers together, 5. Okay, this number here, the 4 and the 6, 10. And then the 6 and the 4, 10. And then the 4 and the 1, 5, and then the 1. All right, I'm out of time. We will pick up, because what we're interested in next class is then what would be the formula, what would it look like to have x plus h to the nth power. What would that look like? All right, so we'll talk about that next time. Have a good weekend. Expect something. I'll send something out via email about the test.
Do you know where the foreign language building is?
Let me turn this off real quick. Do I know